All right, so the next four problems all refer to, in essence, the prisoner's dilemma, or a strategic game. And we can take it back to a duopoly, because in this case we have two players. And in our particular problem, we have Lopes and Home Max, really for Lowe's and Home Depot, because they can't use those real names. And they really compete quite intensely in that real world out there. And so this is a kind of nice problem to illustrate how two firms in a market may compete, or how they think about strategic behavior when it comes to pricing or building new stores. So the problem goes like this. It goes, two home improvement stores, Lopes and Home Max, in a growing urban area are interested in expanding their market share. Both are interested in expanding the size of their store and parking lot to accommodate potential growth in their customer base. The following game depicts the strategic outcomes that result from the game. Increases in annual profits of the two home improvement stores are shown in the table below. So here's Lopes' profit, and so here's Lopes. They can increase store size or not increase store size. If they increase store size and Home Max increases store size, Lopes will make $1 million, Home Max will make 1.5. If Lopes increases store size and Home Max does not increase its store size, Lopes does quite well. It makes 3.2 million versus Home Max's 0.6 million, etc. All right? So we've been discussing how you kind of analyze these games. And the thing is, you want to say to yourself, okay, Lopes is interested in knowing what they should do given and the assumed behavior, in this case, of Home Max. So let's start here. Lopes says, let's assume Home Max is going to increase the size of its stores. What's our best choice given that, all right? So they're assuming Home Max is going to increase their size of the store. So they say, well, if we increase the size of our store, we make $1 million. Home Max, that makes 1.5. If we don't increase the size of our store, but Home Max does, we only make 0.4 of $1 million, and Home Max walks away with 3.4 million. That would sting, okay? So, answer, Lopes says, if Home Max decides to increase the size of this store, no question, we have to increase the size of our store. All right, number one. Number two, then the Lopes MBAs get in the room and they all say, okay, let's assume Home Max doesn't increase the size of this store. So they don't do anything, right? What's our best decision here? Well, if we increase the size of our store and they don't, we do very well at 3.2 million, all right? If they don't increase the size of their store and we don't increase the size of a store, we make 2 million. Well, again, look what's going on here. No matter what Home Max does, Lopes is better off increasing their store size. And make sure you see that. Again, assume Home Max increase the size of their store. Lowe's increases their size, makes $1 million. If they don't, they make 0.4 of $1 million. So, given Home Max increases its store size, the best thing Lopes can do is also to increase store size because they'll do better than if they don't. Now, if we assume Home Max doesn't increase their store size, well, what's the best strategy again? Well, if Lopes does, they make 3.2 million, and if Lopes doesn't, it only makes 2 million. So again, this increase in its store size dominates. It's the most important thing to do, or the best thing to do. No matter what Home Max is doing, Lopes has a dominant strategy, which is to increase the size of its store, irrespective. Okay? So, Lopes is going to increase the size of its store. Let's see what the answers are here. Pursuing its own best interest, Lopes will, well, I've given you the answers here, right? Increase the size of its store and parking lot only if Home Max also increases the size of its, no. Increase the size of its store regardless of the decision made by Home Max. So your answer is C, because no matter what Home Max does, the best strategy for Lopes is always to increase its store size. All right? Okay. Number 8. Increasing the size of its store and parking lot is a dominant strategy for whom? Well, we've done Lopes. Let's go now see what's a dominant strategy for Home Max. So Home Max does the flip. It does the exact same thing Lopes does, but now it makes the assumption that Lopes is going to have a certain behavior. So Home Max says, okay, folks, let's analyze what we're going to do if Lopes goes and increases its store size. Well, if they increase their store size and we increase our store size, we make 1.5 million. If they increase their store size and we don't increase our store size, we only make 0.6 of $1 million. So Home Store says, well, if Lopes increases the store size, the best thing for us to do is increase our store size. We'll make 1.5 versus 0.6. Now the MBAs get in the room and they say, well, let's assume Lopes is little bit slow here, and they don't increase the store size. What's our best strategy? So home max says, well, if Lopes doesn't increase their store size, and we do, we'll make 3.4 million. That is very, very rich, okay? And if Lopes doesn't increase its store size, and we don't increase ours either, because we play nice or something, we make 2.5 million, which is certainly less than this. So in other words, home max also has a dominant strategy. No matter what Lopes does, home max should always increase its store size, because if it does, it will do better than if it didn't increase its store size. All right? What's going to happen? We're going to end up in this box, where both stores playing a dominant strategy, meaning maximizing their profits regardless of the decision made by the other, will both end up here. In essence, the form of the prisoner's dilemma. Both prisoners end up confessing on each other because that is the strategy that guarantees them the best outcome given what the other player may do. All right? So, if you look at number 8, it says, increasing the size of its store and parking lot is a dominant strategy for C. Both stores. It's a dominant strategy. Okay? All right. Number 9. It says, suppose the owners of Lopes and Home Max meet for a friendly game of golf one afternoon and happen to discuss a strategy to optimize growth-related profit. They should both agree to what? All right. Now, here is a form of collusion, right? They're playing golf together. They're saying, look, we're both increasing store size and our profits are good, but they could get better. Now, I'm not going to not do anything and watch you, increase your store size. Me make 3.4 million and you make, 0.4. That's not going to work. If you try that on me, I'm going to respond and increase store size. That'll get us right back to here. However, if we both agree not to increase store size, we'll end up in this box in which you make 2 million for me, 2.5 for you, which is certainly superior to the 1 and 1.5 million we make when we both compete. So again, collusion is going to work. And let's look at the answers here. All right? They should agree to refrain from increasing their store size in parking lots. The answer is B. You should go here. All right? Just as we did in the prisoner's dilemma, the best strategy is for neither person to confess. The problem is you can't trust the other. You don't know if they're going to give you up, because if they give you up, you're really going to be in trouble. So for example, if Lope says, you know what, I'm going to trust Home Max, I'm not going to increase my store size, and then Home Max reneges and goes increase its store size, Lopes takes a real beating, loses a lot of money, and Home Max makes a fortune, which may give them, strategic behavior, ability to build more stores, market more aggressively, whatever. So this would hurt Lopes a lot. So each firm has to trust the other, and if they don't, which often is the case, they end up here. If they could collude and trust each other, this would be their best solution. All right? That's number 9. Number 10. Suppose the owners of Lopes and Home Max meet for a friendly game of golf one afternoon and happen to discuss a strategy to optimize growth-related profit. If they both agree on a strategy that maximizes their joint profits, annual profit will grow by, the answer is D, 2 million for Lopes and 2.5 for Home Max. Essentially, we've got that answer for you, okay? They'll end up here. This is where their profits will grow that year, as opposed to here where they would be. It's not the difference. It's actually what their annual profits will be. So, again, hopefully this little exercise is helpful to you. We've emphasized 2 things that you're, important concepts that you're likely to see in the test. One is this 2x2 box. This is kind of crucial for setting up strategic games and working through dominant strategies. Not all strategies are dominant. The ones we've been dealing with are dominant, and we always come to a Nash equilibrium. And the ones we've been doing, a Nash equilibrium is kind of a non-cooperative result. It's where both firms end up not cooperating, and this is the best they can do in a non-cooperative world. If they could cooperate or collude, they would go here. This would be a colluding or cooperative world. But Nash equilibrium assumes that firms aren't cooperating, and this is where they end up. Okay? They'll do worse if they're in these other boxes. They'd like to go here, but they can't trust the other. They end up there. All right? I'll stop here. We'll get this video posted, and I'm looking for your feedback. Hopefully it's very useful for you when you're studying Chapter 17, those 2 types of problems. Okay? Thanks much.